Curvilinear coordinate systems 14. An orthogonal UVZ coordinate system is defined by the following set of equations that relate these coordinates to a standard Cartesian set. U is equal to x divided by x squared plus y squared, b is equal to minus y over x squared plus y squared, and z is equal to z. And we're going to start with part D of this problem, which says, invert the above expressions and solve for x and y in terms of u and v. So this is our task. Now we're going to, first of all, start with rewriting the given equations. U is equal to x divided by x squared plus y squared. And we also have v is equal to minus y divided by x squared plus y squared. And finally, z is equal to z. So let's double check. X divided by x squared plus y squared minus y divided by x squared plus y squared and z. So that's what we have. Now what I'm going to do is divide the first equation by the second equation, and this is going to give me u divided by v. And this is equal to, because you see these x squared plus y squares will cancel out. So these two will cancel out. And I will have minus x divided by y. So this means I can write y is equal to minus, you can see if y goes upstairs, minus xv over u. Minus xv over u. So I obtained this equation. Then what I'm going to do is substitute this y is equal to minus xv over u into the first equation. So I'm going to substitute this for y. So this is going to be substituted here for y. So this will give me, the first equation was u is equal to x divided by x squared plus y squared. So it's x divided by x squared plus y is equal to minus xv over u. So it's going to be x squared v squared divided by u squared. This way I have eliminated y from this equation. And you can see that one of the x's will disappear. And I will be left with, if I take this into 1 over x parentheses, 1 over x parentheses, I will be left with 1 over 1 plus v squared over u squared. And this means I can take this into the common denominator, u squared plus v squared, and u squared goes upstairs. So let me rewrite this result. U is equal to 1 over x times u squared over u squared plus v squared. All right. Now I want to solve for x in terms of u and v. And I see that on the left-hand side I have u, on the right-hand side I have a multiplier u squared. So one of these u's will disappear. So I will have 1 is equal to 1 over x u over u squared plus v squared, which means I can write x is equal to u over u squared plus v squared. So I have solved for x. Now at the same time, I have y is equal to minus xv over u. So I'm going to substitute my result for x here. So let's write y is equal to minus xv over u, which is minus u over u squared plus v squared times v over u. V over u. Now you can see that these u's will cancel out, and I will be left with y is equal to minus v divided by u squared plus v squared. Okay, so let's summarize these results here. My end result is x is equal to u over u squared plus v squared. And then I have y is equal to minus v over u squared plus v squared. And also z is equal to z. So these are the set of inverse equations that lets us go from uvz to xyz. Okay, so going back to the question, we were asked to invert the above expressions and solve for x and y in terms of u and v. U is equal to x over x squared plus y squared, v is equal to minus y over x squared plus y squared, and z is equal to z. So I've copied those equations here. I've divided the first equation with the second equation. X squared plus y squared is cancelled, so I was left with u over y, v is equal to minus x over y, which allowed me to write y is equal to minus xv over u. Then that was substituted into the first equation for y. So that u is equal to x over x squared plus substituted this for y, x squared v squared over u squared, and one of the x's disappeared. Then I've taken this into 1 over x parentheses so that I obtain 1 over 1 plus v squared over u squared. And writing this with the common denominator, u squared plus v squared over u squared goes upstairs. So this is u squared over u squared plus v squared multiplied by 1 over x is equal to u. One of the u's cancel, provided that u is non-zero. And here I have x is equal to u over u squared plus v squared. And now I also have y is equal to minus xv over u, so I can substitute this for x. So that's what I have done next. Basically, I have substituted this for x here. This allowed me to rewrite y in terms of u and v. So that's what I have done. So y is equal to minus xv over u. X is equal to u over u squared plus v squared. So minus u over u plus v squared times v over u. That's what I have here. One of the u's cancel. So I have minus v over u squared plus v squared for y, u over u squared plus v squared for x, and z is equal to z.